The breadboard circuit I'm showing here is a circuit to take push button information from a remote location and send it over to an Arduino so it can be used to make something happen. And in this case, it's going to make one of 4 LEDs turn on depending on which buttons are pressed. What we're doing is converting the button closures into analog data to send along the lines, and we're putting that data into the analog input 0 for the Uno. And the controller on the right side is actually just part of a voltage divider. That voltage divider consists of the 4 resistors, actually 3 resistors and 1 short on that separate breadboard. And then on the left side we have a 1K resistor, that's the top of the voltage divider. And so with that 1K resistor and those resistors on the left, we can generate a analog voltage that the Arduino can convert into an action. Now I purposely picked the resistor values that I have there on the right to match up with a control unit, a cruise control unit for a car, because this is how data is sent from a control unit, a cruise control unit, to the controller. So the values that I pick there have a particular purpose. This is for something that a viewer sent me. So let's go ahead and try it out here. If I pick the first case here, and I've added a little voltmeter here at the top so you can see what the voltage is. And we'll get in later, we'll get into the whole conversion issue. How is a voltage converted into a number into the Arduino? So in the first case, when I press this button, you notice that the voltage is 0 and the first LED lights up. And that LED is latched on, and it will stay on until another button is pressed. So if I go to the second button and press it, we're actually got 3.44 volts, and that actually corresponds to a command that the Arduino understands, a number that turns on the second LED. So let's try the third, and with the third we get 5.7 or 0.575 volts, and the third LED lights up. And then the last one, when we hit it, we get 2.02 volts, and the fourth LED lights up. So in this case, when I click on this particular resistor, this is a 2.2K resistor in series with a switch that creates that voltage, that 3.44 volts you see. And on this particular switch that I'm hitting right here, that's a 130 ohm resistor, and it called for a 125, but the closest I could find was a 130, so that works fine. It's in the range of what the Arduino can understand. And that gives me about a half a volt, 0.575 volts. And in the last case, I have a 680 ohm resistor, and when I click on that, I get 2.02 volts with that voltage divider. I've attached a schematic here, and if you look at the schematic, R1 is the top of our voltage divider, and our controller interface device is the bottom part of the voltage divider. So looking at the switches, switch 1 is set to cause port 11 hooked to LED 4. It causes port 11 to go high and LED 4 to light up. Switch 2 causes port 10 to go high, which causes LED 3 to light up. Switch 3 makes port 9 go high and light up LED 2. And switch 4 causes port 8 to go high and causes LED 1 to light up. And the way the code is written is every time a port goes high, all the other ports are turned off. So this should be helpful when you're wiring it up. Okay, I've included the overall schematic, and of course you're not limited to the Arduino Uno. You can use an Arduino Micro, an Arduino Mini. You can even use a Trinket or a Trinket Pro, which are extremely small units. So go ahead and put it together and check it out. You'll find it useful for a lot of other things. even though I mentioned the cruise control unit, you could use this for any kind of device that you're controlling with 2 wires. And it's a very efficient way to send a lot of data just over 2 wires. And you know, if you don't mind having the 2 devices wired up, you know, it's a great way to do things. Have fun.